Pinecone explained, real-time recommendations with Python. Learn how to build scalable, real-time AI-driven recommendation systems using Pinecone and Python, mastering skills in vector databases, index management, and system deployment. Welcome to our deep dive into building real-time recommendation systems using Pinecone and Python. Have you ever wondered how platforms like Netflix or Amazon seem to know exactly what you want? That's the magic of real-time recommendations. In today's data-driven world, the ability to personalize user experiences is more crucial than ever. This tutorial will guide you through setting up your own recommendation engine using Pinecone, a powerful vector database, and Python, a versatile programming language. We'll explore everything from setting up a Pinecone project to deploying a recommendation system that's both fast and accurate. Stick around, and by the end of this video, you'll have the know-how to implement your own recommendation engine. To kick off our journey, let's start with understanding Pinecone. Pinecone is a vector database service that is optimized for handling high-dimensional data, which is crucial for AI-driven applications. Vector databases are designed to store and retrieve high-dimensional vectors efficiently, making them ideal for recommendation engines that need to process large datasets quickly. Pinecone excels in this space by offering scalability, speed, and seamless integration with Python. Its ability to manage vectors efficiently allows developers to create applications that provide real-time recommendations, such as personalized content suggestions or product recommendations. As we proceed, we'll leverage these capabilities to build a robust recommendation system.
Now that we understand what Pinecone is and why it's beneficial, let's dive into setting up our first Pinecone project. First, you'll need to create a Pinecone account if you haven't already. This is a straightforward process that begins with visiting their website and signing up for a free account. Once your account is ready, you can navigate to the Pinecone dashboard, where you'll manage your projects. In the dashboard, you can create a new project by clicking Create Project and filling in the necessary details. Pay attention to project configurations. These determine how your data is indexed and retrieved. Following best practices during this initial setup can save time and resources in the long run.
Indexes are the backbone of any database system, allowing for the efficient retrieval of data. In Pinecone, creating and managing indexes is crucial for optimizing the performance of your recommendation system. To create an index, go to your Pinecone project dashboard and select the option to create a new index. Here, you'll need to specify parameters such as the index name, metric type, and dimension. Proper configuration of these parameters can greatly affect your system's speed and accuracy. Once created, managing your indexes involves regularly monitoring their performance and making necessary adjustments. Remember, well-maintained indexes lead to faster query responses and improved user experiences.
With our indexes set up, it's time to integrate Pinecone with Python. First, ensure you have the Pinecone Python client installed. You can do this via pip with the command pip install Pinecone client. After installation, you'll need to authenticate using your API keys, which are available in your Pinecone dashboard. This step is vital for establishing a secure connection between your Python code and Pinecone. Once authenticated, you can perform basic operations such as inserting, deleting, and querying data. Integrating Pinecone with existing Python projects allows for enhanced functionalities, especially when combined with libraries like NumPy or Pandas. This integration is a cornerstone for building a functional recommendation system. Now comes the exciting part: building the recommendation engine. First, define the objectives of your recommendation system. Are you recommending products, content, or perhaps services? Once objectives are clear, develop the recommendation algorithm. This could be a collaborative filtering mechanism or a content-based filtering approach. With your algorithm in place, integrate it with Pinecone to leverage its real-time data processing capabilities. This integration is where the power of Pinecone shines, allowing instant retrieval and analysis of data to generate recommendations. After building, thoroughly test your recommendation engine to ensure it meets accuracy and performance benchmarks. Remember, iterative improvements based on testing results are key to refining your engine. With your recommendation engine up and running, optimization is the next step. Speed and accuracy are critical factors that determine the effectiveness of a recommendation system. Techniques such as indexing strategies, efficient data structures, and parallel processing can significantly enhance the speed of your system. On the accuracy front, fine-tuning your algorithm and leveraging machine learning models helps in providing precise recommendations. It's important to strike a balance between speed and accuracy, ensuring that neither is compromised. Utilize monitoring tools to track your system's performance, making data-driven decisions for continuous improvement. Deployment is the gateway to bringing your recommendation system from a development environment to real-world application. This process involves several steps, including setting up the right infrastructure, such as cloud services, and ensuring your system is scalable to handle varying loads. Challenges in deployment often include managing dependencies and ensuring security. Selecting the right infrastructure that supports scalability is crucial, as user demand can fluctuate. Post-deployment, regular monitoring and maintenance are necessary to keep your system running smoothly and efficiently. This ensures your recommendation engine continues to deliver optimal performance, delighting users with personalized experiences.
Once your recommendation system is live, analyzing its performance is an ongoing task. Use tools for data analysis to understand how well your recommendations are being received. User feedback is invaluable, providing insights into areas for improvement. Implementing feedback loops ensures that your system learns and evolves, offering increasingly relevant recommendations. Strategies such as A/B testing help in refining your algorithms based on real-world data. Furthermore, leveraging AI and machine learning can enhance your recommendation system, making it smarter over time. Continuous improvement is key to maintaining a competitive edge and keeping users engaged.
We've covered a lot in this video, from understanding Pinecone's role in vector databases to deploying a real-time recommendation system. Remember, mastering recommendation systems is an ongoing journey. Continuous learning and experimentation are essential. Explore resources like Pinecone's documentation and Python libraries to deepen your knowledge. As you venture into building and refining recommendation engines, don't be afraid to innovate and try new approaches. We encourage you to share your experiences and questions in the comments section below. If you found this video helpful, give it a thumbs up and consider subscribing for more content on AI and machine learning. Your feedback is invaluable as we continue to create educational content tailored to your learning needs. Thank you for watching.